In this video, we are going to be looking at angle of depression, and the best way to explain it is to take an example. Now we've got this example. The angle of depression of a tennis ball on the floor from an umpire 48 meters away is 32 degrees. Calculate the height of the stool the umpire is sitting on. Now let's try to solve this. So I know you know an umpire. An umpire is someone that kind of regulates things in a long tennis match. Now we are told here that the angle of depression of a tennis ball on the floor. Now it means that we've got a tennis ball probably on the floor somewhere here from an umpire. Remember, I told you that you have to be careful of this word from. So the angle of depression is from the umpire, and the umpire is usually seated on a stool. So the umpire is up here. Now from this umpire, the angle of depression is 32 degrees. Now remember, the umpire has a line of sight. Does that make sense? Now the umpire looks down at the ball, and now he or she makes an angle of 32 degrees with the horizontal. Does this make sense? So this is how we represent angle of depression. And so we are told that the ball is 48 meters away. The angle of depression of a tennis ball on the floor from an umpire 48 meters away. So the ball is 48 meters away from the umpire. Does that make sense? Now we are told to calculate the height of the stool the umpire is sitting on. This is the umpire here, and this is the stool the umpire is sitting on. So we can represent this as height of the stool, and then we complete this triangle. Do you understand? Now before you find the height of the stool the umpire is sitting on, there is something you need to note in angle of depression. Now if you see, we've not found any angles of the triangle aside this perpendicular angle 90 degrees. Now to be able to find an angle, we need to note something. Now can you see this line, which we call the line of sight, and this base of the triangle? They are parallel lines. Now we've got this line cutting across, which is called the transversal, and I hope that you can still remember what I taught you in a previous video: alternate angles. Now can you see this Z-like shape? What that means is that this angle here is equal to this angle here. They are alternate angles. Does that make sense? So it means that this angle is 32 degrees. Do you understand that? So we can now solve for the height of the stool the umpire is sitting on. Now remember, the first thing you want to do is to label the sides of the triangle. The side that is facing angle 90 is known as the hypotenuse. The side facing the angle given is known as the opposite, and then the third side is the adjacent. Does that make sense? Now we are relating opposite and hypotenuse, so you've got to remember SOHCAHTOA. So we have SOHCAHTOA. Opposite and hypotenuse, that is so, which means we are using sine. Does that make sense? So we have the formula for sine. Sine theta equals to opposite all over hypotenuse. In this case, theta is the angle and theta is 32 degrees. Opposite is what? H. And then we have hypotenuse as 48. Do you understand? We slot this into the formula. We'll be having sine 32 equals to opposite is H over hypotenuse is 48. Do you understand? Now we have to find sine 32 with either a 4-figure table or with a calculator. So sine 32 is 0.5299. We have 0.5299. Now if you are using a calculator, make sure it's in degrees, not rad or radian. Do you understand? So we have 0.5299 equals to H over 48. Now remember, this is like over 1, so we cross multiply. Do you understand? Now let's solve the remaining somewhere by the side. So we have H times 1 is H equals to 0.5299 times 48 will give us approximately 25.4 meters. Do you understand?